Hello students, today in this video I am going to discuss the questions from the subject Elements of Civil Engineering which were asked in a preliminary exam in 2018. Question number 1. The required minimum compressive strength of building bricks as recommended by IS 1077, 1957 and 1970 is. Now as per IS 1077, 1957 and 1970, the minimum compressive strength for first class bricks is 105 kg per centimeter square. For second class bricks, it is 70 kg per centimeter square, and the minimum compressive strength for no brick should be less than 35 kg per centimeter square. And that is why the correct option is option number 4 for this question. Question number 2. The minimum compressive strength for rapid hardening Portland cement after 72 hours should be. Now the difference of rapid hardening cement to that of ordinary Portland cement is the quantity of limestone, which is tricalcium silicate, used as raw material, which gives high early strength to it. It gains strength faster than OPC. In 3 days, it develops 7 days strength of OPC at same water cement ratio. The compressive strength of rapid hardening cement after 1 day should not be less than 16 newtons per mm square, and after 3 days it should not be less than 28 newtons per mm square, and that is why the correct option is option number 2. Question number 3. The maximum settlement for the isolated foundation on clayey soils should be limited to. Now they have given 4 options, but as per IS 1904, for clayey soil, maximum allowable settlement is equal to 75 mm. For sands and hard clay, it is 50 mm. For soft clays, it is 100 mm. Now in this question, as they haven't mentioned the exact type of clayey soil, the answer becomes difficult, and that is why in the answer key provided by MPSC for this particular question they have given hash over there. Now next question, as per IS 1893-2002 shown in Seismic Zones of India map corresponds to, and the 4 options are given. Now the latest version of zoning map of India given in the earthquake resistant design code of India IS 1893 Part 1 2002 assigns 4 levels of seismicity for India in terms of zone factors. In other words, the earthquake zoning map of India divides India into 4 seismic zones named as 2, 3, 4 and 5. Unlike its previous version which consisted of 5 or 6 zones, according to the present zoning map, Zone 5 expects the highest level of seismicity, whereas Zone 2 is associated with the lowest level of seismicity. Zone 5 is called as highest risk zone. IS code assigns zone factor of 0.36 to it. Zone 4 is called as high damage risk zone, and zone factor for this one is 0.24. Zone 3 is moderate damage risk zone, and zone factor is 0.16. Zone 2 is low damage risk zone, and zone factor is 0.10. Zone factor of 0.10 means the maximum acceleration is 10% of gravitational acceleration, and hence the correct option for this question is maximum intensity 5, so option 3 is the correct option. Next question, which of the following is a disadvantage of framed structures? Now in framed structures we do get the flexibility in planning, we can achieve the speed of construction, we can achieve the economy also, but in frame structures, span lengths are usually restricted to 40 feet. Spans greater than that can cause lateral deflections. So the disadvantage of framed structures is span length. Next question. What is fineness modulus of coarse sand? Now the fineness modulus is an empirical figure obtained by adding total percentage of the sample of an aggregate retained on each of the specified series of sieves and dividing the sum by 100. The 10 sieves which are used for this purpose are 80 mm, 40 mm, 20 mm, 10 mm, 4.75 mm, 2.36 mm, 1.18 mm, 600 micron, 300 micron, and 180 micron. The fineness modulus for fine sand is 2.2 to 2.6. For medium sand, it is 2.6 to 2.9. And for coarse sand, it is 2.9 to 3.2. Next question. A total station is a combination of. Now we know that total station is a combination of electronic theodolite and EDM. Next, which of the following electronic distance measurements is useful in major construction where alignment is to be done precisely and quickly? Now for this purpose, or in order to have the alignment precise and quick, laser theodolites are used. Option 3 is the correct option. Next question. Reduced level of the floor of building is 74.4. Staff reading on the floor is 1.625 meter, and staff reading when it is held inverted with bottom touching the ceiling of a hall is 2.870 meter. Then the height of the ceiling above the floor is. Now in this case, in order to get the height of the ceiling, what we should do is that the staff reading is given on the floor, which is 1.625, which simply indicates that the height of the instrument is 1.625 meters. And when the staff is held inverted touching the ceiling, the reading is given as 2.870, and therefore the height of the ceiling can just be obtained by adding these two readings, 1.625 and 2.870. So when we add these two together, we get the answer as 4.495 meter. So the correct option is option number 4 for this question. Next question. A lamp at the top of a lighthouse is visible just above the horizon from a station at sea level. The distance of the lamp from the station is 30 km. The height of the lighthouse is. In case of long distances, for long sights, in order to have accurate leveling, the effect of curvature of earth and refraction of line of sight shall have to be taken into consideration. Due to curvature, the points appear to be lower than they actually are, while due to refraction, they appear to be higher than they actually are. The effect of curvature being greater than that of refraction. The combined effect causes the points to appear to be lower than they really are. The correction for curvature is given as 0.07849 d square in meters. The correction for refraction is 0.01121 d square meters, and the combined correction is given as 0.0673 d square. So the combined correction is 0.0673 d square, and it should be in meters. or we get it in meters. But while substituting the value of d, it should be substituted in kilometer. So if we use this formula and if we substitute the values, the answer works out to be, it is 0.0673 into d square. D square is 30 square, 30 square is 900, so 0.0673 into 900, we get the final value as 60.57 meters. So height of the lighthouse is 60.57 meter. Okay, that's all. Thanks.